Hi guys, welcome to Who Code, and this is a solution video for USACO 2018 December contest bucket list. So, this problem states that Farmer John is considering a change in how he allocates buckets for milking his cows. He thinks that this will ultimately allow him to use a small amount of total buckets, but he is not sure how many exactly, and we want to help him out. So when you see small number of total buckets, we are trying to minimize the amount of buckets that are being used. Farmer John has n cows, conveniently numbered 1 to n, and n is in the range of 1 to 100 inclusive, so this is a pretty small number. The ith cow needs to be milked from time Si to Ti, and requires Bi buckets to be used during the milking process. Several cows might end up being milked at the same time, so they cannot use the same buckets. That is, a bucket assigned to cow i's milking cannot be used for any other cow's milking between time Si and Ti. The bucket can be used for other cows outside of this window of time. To simplify his job, Fj has made sure that at any given moment in time, there is at most one cow whose milking is starting and ending, and Si and Ti are all distinct. Farmer John has a storage room that is sequentially numbered with labels 1 to 3 and so on. In his current milking strategy, whenever a cow I starts at time Si, Fj will run to the storage room and collect Bi buckets for cow I, which would be Bi, which is how much the cow needs for milking. And we want to determine how many total buckets Fj would need in order to keep a storage room in order to milk all the cows. So the first input contains n, and the next n lines will describe each cow, so their starting time, their ending time, and the amount of buckets they need. They are all separated by a space. Both Si and T are integers, and Bi is in the integer range 1 to 10. So this doesn't really matter, but this, since it's in range of 1 to 1000, is also still pretty small, so this could be a brute force solution. And we want to output a single integer telling how many total buckets Fj needs, well, the minimum total integer. So, because you can have infinite buckets and that would work. So we wrote the minimum. So we would have 3, cow 1 starts from 4, goes to 10, and yes, so on. And if in this example, Fj needs 4 buckets, he'll use 1 and 2 for milking cow 3, starting at time 2, and yeah, this is the explanation. But I will get into drawing a diagram for you guys. So this is a drawn out diagram and explanation on why the answer is 4 for this particular test case. So since the ranges of each cow will only be in the 1 to 1000, that means we have enough space and storage to draw them out, map them out onto a number line, or we can also use an array and just mark 1 for the ones that are needed. So at the start, we can just draw out this number lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We only need to go up to the max number in the range, but that doesn't really matter. You can just set that one to 1000, but I'll just draw 13 for this test's sake. So we have cow 1, we have 1, and then 3, 4, 5, 6, and then 4, then 7, 8, 9, 10, and 8, and then 13 right here. So this is cow 1's range, this is cow's 2 range, and this is cow's 3 range. So how did we get 4 as our answer? So we can first mark, so this first cow range is 2 to 4, time in 2 to 6 is 2 to 6. We'll need 2 buckets, and then the cow from 4 to 10 will need 1 bucket, and the cow from 8 to 13 will need 3 buckets. So how this will work is, so we would first have to add buckets to our storage in the first cow when it starts. So we will need 2 at the start, and then after, since these 2 buckets are still being used, we will have 0 in our storage. So when this cow starts, we will need an extra bucket for this cow. And well, we don't need 3 buckets, we don't need to add 3 to the storage for this cow, because once this cow starts, we are using these 2 buckets are done being used by this cow, since this range is bigger and this cow is not being milked anymore. But since this cow is still using bucket 1, we will need to add one more bucket. That's 2 minus 3, we need one more bucket, and 2 plus 1 plus 1 equals 4. And that's how we get our answer 4. So this problem might seem a little daunting at first, since we need to keep track of a lot of things like the start time, the end time, and how many buckets we're using, how many buckets we need, and so it will be a little complicated, but there is a really nice algorithm, something called prefix-sum, that could be used in this problem. So what prefix-sum is basically a method that keeps track, it builds up its answers like as we go along this list. So for example, if I were to want to keep track of the amount of rain gained in like a bucket on said day, then we can say on day 1 we have, let's just say 7 units of water or rain, whatever, in a bucket. And let's say on day 2 we got an extra, let's just say 3, and on day 3 we got an extra 2. So here it will be and if we want to find day 3's amount of water, and we're also expecting that no rain will be lost or taken out or like removed from the bucket, so just like continuously adding on. So if we want to find day 3's bucket, then we would have to add up every single one. But like if we wanted to find days like just a bunch of queries on like day like 10,000's amount of rain, right? It'll be kind of inefficient to just go through the whole like amounts of rain like one by one, and then like adding them all up. And then like if we had like multiple queries, let's say like the next one would be like day like 1 billion, like that would be too inefficient and it'll time out. So what prefix-sum does is that we can start it, we start it at 0, since we need to add the I minus 1 to the next iteration, because it'll build up. So on day 7 we'd have 7, and then on day 2 we would have 3, but 3 plus 7 is 10, and on day 3 we would have 10 plus 2, which is 12. This list is a little long, but that is the general idea of prefix-sum. This method might be a little inefficient, since we would have to go through, it'll be inefficient for when we have a bunch of ranges like this problem, and we would have to go through each subarray or each range and increment every single time per range we get. And if the ranges are too big, then we will cause a time limit exceed. Well, this problem actually isn't very strict on time, since the numbers are very lenient. It's only 100, like at max it's only 100 times 1000, which it won't even be, because SI, they're all distinct, but at most it won't be a really big number. But just for this just for another for learning purposes, I'll show you another method. Another version of this prefix-sum that is used a lot I like to call that the start and end method, since you only mark the start and the end, the end plus 1 of every range to see if you're using it or you're not using it anymore, which is a very creative name. But so for example, if I had a range of 1 to 3, then I would mark the index 1 as 1 as I would mark the index of 3 plus 1, which would be 4, as, let's just say it's 1, 2, 3, and then 4, I would make it -1, since when I get to 4, I am not using a 1 anymore, so I would subtract 1, and then I would just use the prefix-sum, and that prefix-sum will get 0, and it'll be 1, 1, 1, and then 0. Since at index 4 I will not use, since I still use it in index 3 since it's inclusive. So this method will be much better for this problem's sake, since we have a lot of ranges, and we can all we have to do is mark the start and the end plus 1 in the amount of buckets. So we signal that, at index 2 we need 2 buckets, and once we're at index 7, so after index 6, because 6 we're still using it, so when we're at index 7 we can just do -2 since we don't need that 2 buckets anymore, and we can mark every single one and then go through the prefix-sum once and find the maximum or the busiest time that we need the buckets. So that would be our answer, since we would need at most that many buckets in that amount of time. So this is it's a little confusing at first, but I can draw it out right now. So we have our index 4, 2, 6, 4, 10, 8, 13. So 2, 6, 4, 10, 8, 13, and it's 3, 1, 3, 2. So, and I would get, let's see, 2, 1, 3. Okay, so now I can draw my number line, and I have 1, 2, 3, 4, 5, 6, 9, 10. Okay, 14. So for this, I'll just make it one indexed for this graph's sake, just to make it easier for me to draw. But the idea is still the same more or less. So it doesn't really matter if it's 1 indexed or 0 indexed. So at index 2, I would need 2 buckets. So index 1, 2, I would need 2 buckets. And then index 6, I mean 1, 2, 3, 4, 5, 6. But it's not index 6, it's at index 6 plus 1. Because at index 6, I'm still using 2 buckets. So instead of 6, I would make it -2 here in index 7. So, and then moving on to the next cow, index, the second cow at index 4, so 1, 2, 3, 4, I would need 1 bucket. And at index cow number 11, since it's 10 plus 1, I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be -1 because at index 11, I don't use the first bucket anymore. Well, it's not really the first bucket, it's like 1 bucket anymore. So, and moving on to the next cow, at index 8, 1, 2, 3, 4, 5, 6, 7, 8, I would need 3 buckets. And at index 13, 9, 10, 11, 12, 13, by index 14, I would -2 buckets. So now, and I have I marked all the starting and all the endings plus 1, which is how much I need. So after that, I can just go through this whole thing one more time and add up, I don't even need this underline, and add up all just the prefix sum and do a prefix sum on all this. So here, this one doesn't really matter, so I'll just skip it. So here, number 2, so it'll be 2, 2, 3, 3, 3, 1, 4, 4, 4, 3, 3, 3, 0. So it'd be like this. And since we want to find, I guess, the busiest time period, which is here, and the busiest time, which is basically just the maximum amount in that list. So that is 4, and that is how we get 4 as our answer for the sample test case. So now let's get on over and start writing our code. Okay, so I am now in my online IDE, and I just have my standard libraries. So now we first need to see in everything that we need, and we would need an array of numbers, and we would have our m. Okay, so m, I just did it for our max range. It's not very necessary since these numbers are still fairly small. It'll like 10 to the 4. It doesn't really matter. So it's just it's not necessary, but I just did it to hopefully speed up the smaller ones, but it doesn't really matter. And a funny thing that I found when using an array is sometimes it'll like initialize everything to like some weird number that's not 0. So what you could do is you can just memory set it. So this is how you would memory set memset, and it'll make every single element in this array R and set it all equal to 0. I could set it to 1, but for this one I won't, so I just set it to 0. So for our prefix sum to make it easier. And now I would just input everything that I need are in our start, our end, and the amount of buckets that we need, and I would cin them all. And so, as explained before, I would mark the start of the array with however much b I need to signal, okay, at this time period I am using this many buckets. And as also explained, I would mark the end plus 1, since at the end I am still using the bucket, but at e plus 1 or at the end index plus 1 I am not using the buckets anymore. So all I have to do is set it equal to negative b. Oh right, and one thing that we also need to do is we need to plus equal, since a cal can start and another cal can end at the same time, so to like collisions, so I would just plus equals, so that should also be a thing to watch out for. And then again, this is really unnecessary, but I just did it to hopefully like speed up the small test cases. So now all we have to do is do our prefix-sum and our standard prefix-sum, and just do plus equals, and there is a prefix-sum where I would just add the ones before, and then I'll index it. I start at 1 since we need to I minus 1, and then at the end I could just see out the max element needed, and m would be my search range. So there, and that should work for a test case like this. So as you see, we got 4, and that should be our answer. And now, since this problem has it's a pretty old problem, so we would have our free open blist.in, blist.out. So over here I can just copy and paste some things I wrote before just to save some time. I love this. It's good, and I can just put 2 pieces. That's fine. And then go. And as you see, we got all the test cases correct. So I would highly recommend searching and learning about the prefix-sum and its variations, since there's like 2D prefix-sum, and the start and end prefix-sum. So there's a lot of prefix-sums, and they're all really useful for many problems, especially like this one. And yeah, it's a really important algorithm to learn, and I highly recommend learning about that like by yourself, since it's really important. And that's it. So thank you for watching, and I hope you learned something from this video, and feel free to ask any questions below in the comments, and I'll try my best to answer them.